give us two images or two pictures, a picture right there and a picture right there. It looks like they are both hexagons, and they ask us two questions. First of all, they want to know what type of a dilation is happening in this picture here, and that just means, is the thing getting bigger from start to end, which we'll call an enlargement, or maybe the shape is getting smaller from start to end, which we would call a reduction, or maybe the shape is staying the same, and if that was happening, we'd call it a congruence transformation. We can see it right now that both shapes are different sizes, so we know that in this problem it's not a congruence. It'll either be an enlargement or a reduction, and we're going to have to figure that out. After we do that, they also want to know the scale factor. So once we know whether it's getting bigger or smaller, then we have to figure out how much bigger or smaller, and that'll be the second part, the scale factor. So let's do this part first. Let's figure out whether this is an enlargement or a reduction. To do that, we have to read this part up here. So it tells us, and this is important, it tells us that this shape right here, which we can see is this one, it says that that is the image. What you need to know is that the image is the, it's like the second one, or it's like the ending after the problem was done. So this right here is the image. It's like the end of the problem. And if that was the case, then that would mean that this one, the hexagon that has an M in it, that must be the start. Another way of saying that would be that this is the image, and the start is the pre-image. So what type of a dilation is it? Well, it looks pretty clear that from start to the end, the shape got smaller. And when things get smaller, we call that a reduction. So what type of dilation is this? It's a reduction. So we're halfway done. The second part, they ask for the scale factor. So once we know that it is getting smaller, or it is a reduction, how much smaller is it? That the scale factor tells us that. And there is a really simple formula for scale factor, and it is image divided by pre-image. And if you just want a simple way to think about that, another way of looking at it is it's the same thing as the end divided by the start, or the beginning. So let me show you what I mean by that. So to get from, let's just try to work our way all the way across the image, which we said was this one. To get all the way across that shape would be 1, 2, 3, 4. So that's how big, in one sense, the image is. It's 4 across. So I'm going to put a 4 right there. That's the image. How long would it take to get all the way across the first one, or the pre-image? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So the pre-image was 8 across. So for the scale factor, we just take those two numbers, the image divided by the pre-image, or you could think about it as the end divided by the start. And we can reduce that, and that gives us 1/2. So we could say that the scale factor in this problem here is 1/2. That's how much smaller the end was. It's half the size of the starting one. Or you might like to write that as a decimal, and you could say that the scale factor is 0.5. I think I like 1/2 better, but both are a good way of writing it. And that is how you do this. Good luck.